How's it going, everybody? My name is Jim, and welcome to Restoration Projects. This video is going to be going over how to replace the bearings in this Delta triple duty grinder. So, from best guess, this thing's a 1937, and I'm willing to bet money that the bearings in this thing are original. It still spins fairly freely, but it squeaks a little bit. The bearings just don't feel as smooth as they should. So I want to replace the bearings in it. So I wanted to do this video just kind of showing the process of how I go through that. For the bearings, I was able to find these on eBay. So they sell these as for the Delta triple duty grinders. They have these spacers in here. So the old style bearings, they had extended races. So it would kick out the center portion. It would kick it out a little bit from the rest of the housing. Since they don't make those types of bearings anymore, what this individual has done is they've added these extendable, they're like washers essentially, to make up that spacing. So think of it as spacers, that's a better word than instead of washers. And this is supposed to be a good retrofit for these. All the reviews said that they worked really well. So you can find those on eBay. I will try to list on the description below who makes them. As far as taking this thing apart, it's going to be pretty straightforward. I haven't been into this one before, so I don't know if it's a pressed-on fit. Some of the videos I found online showed that these bearings were actually retained into the housing with a set screw, so we'll just see when we get in there. So I'll put the camera up on a tripod, and we'll get to tearing this thing apart. Okay, I wanted to bring you guys in closer here so you can see exactly what I'm doing. So this is the back flange, and this back flange, pardon my glove, the camera's not focusing here, is held on with this fine thread nut here, and that's just holding this thing back in here. So when you go to take these off, these things don't just slide out like a lot of the newer import models that you'll see. They're actually bolted on here. So that one, since it was on the right hand side of the grinder, I would put the impact gun in reverse, came off. So this one, I believe, is going to be a left hand thread, just because of the way that this thing turns. You want this thing tightening when it's in gear, or when this thing's operational. You don't want it to self-loosen. So I'll get the impact gun and try it on this side and see if it comes off the way I think it does. Alright, I want to get a close-up here of how this sets in here. So we have this dust shield here. It sits on in this way. Then right over on top of it, we have the main casting here. And then you have the inner spacer. So this is what the wheel backs up to. And that goes through the hole here. But here's something really kind of cool. And when people say they don't make them like they used to anymore, this is what they're referring to. So if you look at this dust shroud here, this has a felt liner in here. It's kind of hard to see from the outside, but hopefully this is focusing on the camera. You can see there on the inside that is felt there. It's what happens is this is up here. You have this extended part right here that comes off of the back of the wheel support, and it creates a dust seal right here. So just a little bit of felt in here, and as this thing's spinning, that felt is doing its best to keep the debris out of here. And when you look at it, there's not a whole bunch of dirt and grime and stuff that's gotten back here. It's relatively clean. I'll bring it in closer here so you can see the inside of the bearing. And that housing in there is relatively clean. This discoloration right there, I think that's just grease and oil that just leaked out over time. These bearings, since they've been in here since 1937, and it's what, 2023 right now, so I'd say they're more than due for a change out. So, but it was just kind of a neat little, it's a little touches like this, like a dust shield to keep grinding dust from going into your motor that you don't see on import machines anymore. Okay, I want to bring you in here and show you what exactly we've done. So this is sort of oriented. This is the left side of the grinder. If you look inside there, you have a spring. I don't even know what it's called, but that's what it looks like in the package. It's just this black spring, essentially, that is designed to keep preload on that bearing and keep it pushed out toward the outside of the housing there. You can see in there, see the finger sticking out. This is what it looks like in real life, and this is how it orients. So these little fingers are sticking out. The main body is in toward the housing. Okay, this part came off a lot easier than I was anticipating, but there's our look inside here. There's this white powder here on the fan fins. I don't know what that is. Could be anything from corrosion buildup, like if it's a aluminum fan fin, or it could be something as awesome as asbestos. Who knows? I'm not going to try to scrape it off, just in the off chance it is something that's going to be toxic to my lungs. So, same thing over on this side. This one came loose, but this has also got the starter set up in it. So, I'm drawing a blank, so I'm probably speaking completely out of term, but I think this is a split phase motor, so it has a starter set here, and then this is the main winding. I'm probably butchering out all those pieces, so don't quote me on this. I'm not an electrician. So I'm going to see if I can push this shaft through and pull this off. Try to get that bearing out of it. So right here, what we're looking at, this is going to be on the right-hand side of the grinder, and that is the contacting switch that the centrifugal clutch will actuate. So what happens is when a motor is starting up, it's in the starting phase, and when it gets the right RPM, it will click that switch out and allow it to spin up to the full load or full RPM speed. That's my rough understanding of this. I'm not an electrician by any stretch of the imagination. I'm just a hobbyist, and this is my general take on how this works. So if I'm not using the right terminology, that's why. Right here, so on the shaft here, you can see the centrifugal clutch. So you have that spring there, and what happens is that holds it in place, and then when it starts spinning, the RPM gets fast enough that it will cause those two wings right there, those brass wings, to flip out, and it will pull this black piece of plastic and suck that in. And that's what's actuating that contactor switch that we saw on the inside of the cast iron housing there. All right, here is the arbor, or the shaft that goes into the grinder. And imagine, if you will, you have a bearing right here. And this is the part that sticks out that the grinding wheel goes on. And it is out of true. So it's about 35 thousandths out. So from 0 to all the way down to about 65 thousandths. And the way this happens is you have a bearing here. You have your grinding wheel hanging out here free in space. And at some point in its life, someone was probably grinding a part. They had too big of a gap between the grinding wheel and the tool rest, and that part got sucked in and bound up between the tool rest and the grinding wheel. Now you have a 7-inch diameter grinding wheel on both sides. That's a lot of rotating mass to come to a complete stop all at once. And when it happens, I believe that that's what bent this out of shape. So the plan here is to try to heat straighten this. So we find the high spot. So go in this direction. That's the high spot. So right now we're at the high point. So this thing is bent up. So it's like a U shape like this. I'll put some heat on here and then quench it really quick, and that should straighten it out. The rest of the shaft is relatively straight. So you go back a little bit further here, and we only go to 70 instead of 65. Go back past these threads here, and there's a little bit of a wow there, probably about 15 thousandths, but not much. And when you go to where the bearing would sit, you have maybe 6 thousandths run out, so I can live with that. Once you get on the other side of where the bearing lives, and this is on the internal shaft here, you do have maybe 5 thousandths to run out. And remember, when you have a bearing here, you didn't just bend this shaft down. It was that grind, or say whichever direction the shaft bends. Say it bends down, it's going to also bend the other part in the opposite direction, because that bearing surface right there, that is the fulcrum, right? That's the middle. Think of a seesaw effect. You put a ton of force on one side, you're going to get a lesser but a little bit more result on the backside here too. So I'm not surprised that this whole thing is out of true. I don't know how true these things come from the factory. This is a 1937, so not expecting like it to be zeroed out like precision, but I think 4 or 5 thousandths I can live with for the rest of it, but I do want to get this major bend out. So what I'm going to do is I'm going to set the probe up right over here on the tip, and we're going to add some heat right in here, try quenching it, and see if we can't bring it back to straight. So there's the highest point right here. So the goal will be, I'll put some heat in here. And I'm just going to mark the high points right here too. So I'll map it out. So that dot's a high point. Put that on both sides here so you can remember. We'll go back here, same thing, and just make sure there's not a twist in it. So all my dots are lining up straight, so that's telling me that it's not so much twisted, it's just bent. And I am no expert at this, I am just an amateur at best, so we're going to see what I can do here. So I've tested this theory out on how this works on a couple pieces of scrap steel I have laying around, so we're going to try it on this. We're going to add a little bit of heat. I'm not going to go too crazy with it, but I'm going to add it right here and see if I can't bring it into true. So Spin it around one last time. Find my high spot right there. I want a little bit lighter with the heat on this one just because I don't want to warp it too much, and this is a different type of metal than what I was using before, so I want to see how it reacts to the heat. So that heat does soak through this part rather quickly, so I'm just trying to cool it off here, bring everything back into equilibrium, and we'll take another measurement here. So we'll spin it around and see what happens here. So didn't seem to bend it down out too much there, so what I'm going to do is I'm going to add just a little bit more heat, and we're going to try it again. So we've done multiple heating and cooling cycles on a shaft, and this is the result. So we've taken it down from about 35 thousandths to about 15 thousandths right here where the wheel will be riding. Like I said, this is my first time ever doing this, and I'm happy to have this down from 35 thousandths down to about 15 thousandths. So, and you can see, as we take other readings going along the shaft here, this one's closer to 5 thousandths out. Go right to where the bearing will be sitting, and you're pretty close. You're maybe 1 or 2 thousandths out. So, and if you go all the way out to the end here, you're closer to that 20 thousandths mark. So, luckily this is where the nut rides. It tightens up pretty good here. So realistically, the grinding wheels would be riding more in this area here. So that's why I'm taking this measurement and saying I have a 15 thousandths deviation. That's what the wheel is going to experience when I reinstall this. So for my first time, I'm really happy with how this came out. Never done this before and didn't realize it was a thing until I started Googling how to straighten these spindles. So we're going to clean this up here. I'm going to go over this with a Scotch-Brite pad, just get it cleaned up, get the rust off of here, and we'll get this thing reinstalled. With these new bearing sets here, it does come with spacers, so I can put these spacers in here to kind of try to get the same size as what I would have had with the original bearings. So I didn't I'll have it going in like this when I install it. So it comes in from this side. So what we're going to do, we're just going to screw this on here. This is just the retainer that holds your bearing in place. Just using a flathead chisel here to get this in. Now, I put my spacer on here. I'm going to come in from the other side. Careful I'm not hitting anything on the way through. Just carefully walk it over through. So, there we go. Now that side's in there, you can now this. We're going to test this out first. So what we're doing, so you notice I don't have that guard on. And what I want to do is I want to install this shaft here, make sure that everything's lined up, and do a test run on this without the guard in place to make sure that I've set this in here properly. So these are all bolted down, so all we need to do now is go to the other side. Now for the install on the other side here, this is the components. You're going to have the housing here, has this metal washer. Make this come into focus in the camera so you can see. So you have a little thin metal washer that goes in first. Then you have your spacer here that goes in second, prong sticking up, and then you have your bearing. This spacer here that's designed to go on the back side of the bearing. So the way it'll go is you have the spacer on here, and then the bearing goes down on the end of the spindle here. The way that this works best is if you put this spacer in here, and then the bearing on top of it. It's not going to fall through that hole there because it's too narrow. And then on the other side, you'll see. Try to get this to focus in here. You'll see that spacer just floating in there freely. We just need to line this up as I'm putting it on the shaft, and then once it's the spindles through both the spacer and the bearing, it'll line up properly and provide the correct offset that we need. So we have those installed. Now to put this on here, we're going to see that it's discolored on the bottom, a little bit brighter on the top, and that's how this machine has been. It's kept clean on the top, but oil over the years and other stuff has dripped down to the bottom. So you can just see a little bit of discoloration on the bottom side. I don't know if that shows up on the camera, but if you have one that does not have a good way to tell which is up and down, maybe make a mark on it using a Sharpie or something, or some way to remind yourself which orientation this goes. It most likely doesn't matter, but you want to put this thing back together the way that you tore it apart, because if it is off just a little bit, then you can cause problems that weren't there to begin with. So what we're doing is we're just trying to get these to line up and go into the holes on this end of the shaft to line up and go into the corresponding holes on this cap. So we have it set in here, everything's lining up, and so what I'm doing is just wiggling it back and forth, trying to get it fully seated in here, because the more pressure that I can put on it with my hands instead of relying on what these little threads here can offer, I don't want to strip these out. So if I can just push it together and then grab the rubber mallet, just give it a little tap in here just to get it set in there. Ideal. So it's spinning freely, doesn't feel like it has any catching or anything on it, so we're going to throw on the nuts here. Okay, so I've got this thing running, and what I had to do is I had to spend a lot of time here loosening one nut and tightening the other, and what that will do is that will allow the shaft to play. So there is side to side play in this. So if you can hand tighten these, you get enough play, you can move it back and forth, and then when you have it in the right spot, you can lock it down. And by right spot, I mean making sure that contactor, that centrifugal clutch, is making the right contact with that starter switch. So yeah, this just took basically moving the shaft all the way to one end here. So because this is the side that the contactor switch is on, so they want it all the way on this side is where it feels like it's making the best contact. So all the way over here, fires right up. Sounds just like it did before I got into it. Just sounds a little bit smoother actually. That high pitch whine that you're hearing right there as I'm turning it, that is that clutch, that centrifugal clutch pressed up against the switch. So yeah, we have this thing set here. There's a little bit of vibration. You can see it when I turn it. I mean, I can see it bouncing there. It's more toward the tip there, but like I talked about earlier, we got this as true as we're going to get it with the skill set that I have and the tools that I have. So it is better than what it was before. So what we're going to do is we're going to pull off these braces right here, these nuts right here, and then we're going to put on the dust guards and start the reassembly process of this. Okay, we are all done with this. Did find some surprises in here. Obviously, having to straighten the shaft, and this was not something I was expecting to have to do. I was thinking this was going to be a pretty easy removal of the old bearings, put the new ones on, put it back together. I wasn't expecting it to take as long as this did. But a couple things I learned. Obviously, your centrifugal clutch, everything is on the right side of the motor here. So I should have just popped this end off and removed the shaft this way. I thought I was going to be able to slide the shaft back and forth and get the bearings to pop out. I may have bent the switch that the centrifugal clutch hits into. So we had to go back in there with the screwdriver and just push on that, try to get that piece of copper, because it's just thin plate copper, so it bends relatively easily. Had to get that back in place. Once we got the shaft out, obviously we found out that this was bent here. I'm guessing at some point in its life that somebody was grinding something and it got sucked in between this tool rest here and the grinding wheel, probably brought the whole machine to a stop, and that is what bent it. So they will set up on a lathe and do some heat straightening using a oxygen and propane torch. Never done that before, and it worked really well. Obviously it didn't get perfect, but for my first time ever doing it, I will take it. Put it back together. If you're going to do one of these, especially on the first generations of these triple duty grinders, I would recommend getting the bearing pack that comes with the spacers instead of the built-in offset or expanded race, because those spacers allow you to set up the spindle here within the proper tolerances, because you only have a very slight tolerance for that centrifugal clutch to be able to operate, to turn that switch on and off for starting it. So there's quite a bit of fidgeting I had to do to get this spindle at the right side-to-side location, if that makes sense. Cleaned up the wheels, got these wheels back on here, dressed them up with a diamond dresser using the factory dressing rest here, so it is perpendicular to the rest of the machine. And we're back in business. This thing takes forever to spin down. It runs really smooth, has a nice hum to it. It's just really smooth machine. Really happy with it. Glad I did the bearings, because I didn't realize that this side of the spindle was damaged, and I got to learn a new skill of doing heat straightening. So that was a cool thing that came out of this too. I'm not going to restore this. I'm going to leave it the way it looks. This is 86 years old. And it's, I think, for 86 years old, in pretty darn good condition. So I want to leave it looking the way it does. It's original paint, and again, people like me come along, we see something, we want to restore it, quote unquote, so we strip it all down, we paint it, but when you paint something, you take away from the originality of it. I like the fact that this is how it looked when it came off of the assembly line 4 all those decades ago. Obviously, it didn't have as many scratches and didn't have the little rust stains here, but, I like the way it looks, so we're going to leave it this way. Anyway, if you guys got something out of this video, please hit that subscribe button, smash that thumbs up button. It helps out the algorithm. And thank you guys for checking out these videos. I really appreciate it, and have a wonderful day.